Hi, in this video we will start with analysis of variance, popularly known as ANOVA. First we will discuss about its use in statistics, and then we will go for basic definitions and then the assumptions, because there are some assumptions you have to care about regarding ANOVA, and we will talk about some linear models, those are used in ANOVA, and the application areas where ANOVA is being used. Now first we go with definition of ANOVA. It is a technique, or more specifically it is a systematic procedure. Now with this procedure what you can do, in each data there must be some variation, right? Now with the help of ANOVA you can partition that variation into several components. Now for doing that, that data must be under some certain circumstances, and of course the partition matters with the nature of classification of data. Clear? For example, the total variation may be partitioned into between the groups and within group variability. Okay, so here is a visualization that you have the total variability of the whole data or the whole data set, and that total variation may be partitioned into within group variability and between the groups variability. Okay, now shortly I will go with an example about this within group and between the groups. Now before that, you should take care of these two causes that actually are responsible for the variation. Okay, the first one is assignable causes and the second one is unassignable or chance causes. Okay, now what is assignable causes? Those causes that can be detected, measured and controlled. Say for example, there is a machine and it packs milk. Okay, now from this side, suppose the milk packets are coming out, okay, like this, it is coming out, and this one is pack 1, this one is pack 2, this one is pack 3. Now the net weights of each packet will not be exactly same. There must be some variation between weights of these individual packets, right? Now if we can see or we can detect the cause of this variation, say for example the operator is a new operator here, he is not an expert and he may do something wrong with the operation of this machine. For that there may be a variation in the packets, right? Or there may be some voltage fluctuation there going on inside, which is actually hampering the performance of the machine, and we can see that the voltage stabilizer is not working properly, and for that reason the machine is not working properly. So we can detect these causes and we can try to rectify these so that the variation can be minimized. So these causes are assignable causes. Okay, and there are some causes called chance causes which is not in our control. Say this man is working over there for the last 10 years and there is no voltage fluctuation there. The machine has been serviced properly and it is working properly. So nothing is visible for those variations, for those small variations within these packets. So what we can do? So the causes of those small variations in the weights of these packets is actually out of our control. So those causes hidden and which we cannot control, those causes are chance causes. Okay, now here you go with the information here that between the groups the variation is due to assignable causes, and within each group that variation is due to chance causes. Okay, now we will see shortly what is going on here. Say there are 3 colleges, we have randomly selected, and we have selected 4 students, that is also randomly from each college, and we want to take an IQ test. Okay, so there are 12 students here in total, and for the sake of simplicity we have taken here 4 students from each college. Actually this count of student from each college may not be same. Now after taking the tests we have got the scores like this, that is Y11 belongs to the college 1 student 1 and the score is 95. For the same college 1, that is Y1, and the 2 means the student 2, that student has scored 98. So in this way we have got 12 scores from these colleges. Okay, now we are interested in finding out the variation among all the 12 students, regardless of the colleges. So what we can do, you take the mean, x bar, and you take the xi's of those 12 students, that means x1, x2, x3 up to x12. You find the gaps between this xi's and that mean, and you square it. And after squaring all those gaps, you have the sum. And that is the variation of all those 12 students regardless of the colleges. Okay. Now, one thing I will ask you to notice here, that we are discussing about variation and not variance, because variance is actually the mean of variation. So we concentrate on variation only, right? Okay. So here we go. The mean x bar. So we add these values, that is 95, 98, 90, all those things, and we get this mean over here, that is 86.67. Now from that mean, we find out the gaps of those data points, that is 95 and that mean, and we square it. Again, it will be the same thing for 98. We find out the gap between 98 and the mean, and we square it. We have those squares and we add those, and we get 932.67 as the variation. Now I repeat, this variation is actually regarding to the whole data set, regardless of those colleges. Okay. Now I will show you visually actually what is going on. This bar is standing at 86.67. So this is actually our mean. We have this data point 95 and we find out the gap. 98, we find out the gap. On the left hand side of this mean, that is 75, we find out the gap. Now in this case, the gap may be negative, and you have those gaps squared and summed up, right? Now this total squared gaps is your variation. Okay. Now get into this college 1 now. Within this college 1, this one is x1 bar. This 1 here actually indicates the mean actually belongs to college 1. So this one we have got 95. So we can have the variation within college 1 following the same procedure, that 95 is your mean and 95 is your data point within the college 1, that is y11. Then you find out 98 minus 95, that is this is the data point or the score of the second student, y12, and this is the mean. You find out the gap and square it. In this way, if you have this summation, you will get 38. So 38 is the variation of college 1. Next, you can have the mean of college 2 as 77 and college 3 as 88 here. And you can find out the SXX like this. If you name it 2, you name it 1 here, and you find out following this formula, and you can find the SXX 3 here also, and you can compare. Now following this procedure, what you get actually, what you can infer. If I ask you, do the IQ levels of the students of college 1 differ? That means I'm talking about only college 1. That means within the college 1, there is a variation 38, right? So can we say the IQ levels of the students differ in college 1 or in college 2 or in college 3? Separately, I have 3 questions. So by ANOVA or the analysis of this variance, of this variation, you can answer these questions. Also, if I ask, as a whole, the scores of each college differ. Now, the first college is having 4 scores here, the second college here 4 scores, and the third college is also having 4 scores. Now, if I ask you the standard of those colleges regarding performance of the students, so do the colleges have any effect on the scores of the students, that is the performance of the students? So you can answer these kinds of questions by performing analysis of variance. So these 3 questions belong to within group partition, and this question actually belongs to the between the groups partition. Okay. In the next video, we will come across the terms and the definitions that are required for learning ANOVA. Right?